Hello, this is the second part of chapter 4. Now we're talking about outer joins and some of the um, lesser common table manipulations. Okay, so there is left outer join, right outer join, full outer join. Outer is complementary, it's not necessary, uh, but left, right, and full is, otherwise it will be just join, which is an inner join. It does look a lot the same, but let us talk through the meaning of this. Unlike join, left outer join keeps the unmatched rows from the left table, from the first table. Similarly, right join from the second right table. And full outer join keeps unmatched rows from each table and populates the missing values with null. Here is an example. We are doing left join of vendors and invoices. We're choosing certain columns that you can see on your screen, and we're joining on vendor ID as we did previously. So let's examine the results. So for Ebby office furnishings, there is an invoice number and an invoice total. For other vendors like American Booksellers Association, there was no corresponding invoices and hence no invoice number and invoice total, so there is no values there. For the sake of next examples, let's look at these three tables and study these tables carefully. If you like, you can stop the video and just look through these tables. Also, they are in the book. So there is departments table, department name, and department numbers. There is employee ID and names, first, last name, department number. So those department numbers correspond to these department numbers. And you can notice if you look carefully that there is department number 6, which is not listed. Either probably because this table was cut off at 5 to keep it smaller, or for some other reason department number 6 is not listed in this table. Projects table, so there is project number and there is employee ID, the same as presumably primary key for this table. Let's be careful here. If we examine the values of employee IDs in two tables, we see that there is a project number and some employee ID that is not mentioned in here for whatever reason, and maybe it was cut off or the employee was fired, terminated, and so this is the tables that we are working on, and this is where those are good tables to see the meaning of various joins other than inner. So we are doing left outer join. The outer may be omitted if you need it, if you choose. So it's just left join of departments and employees. We are keeping department name, departments, department number, and last name. Over here we have to qualify. Department number was a column in both tables, departments and employees. Sorry. And of course we are identifying them on department's number. So we got some values accounting, department name, department number, and last name of the person in that department, but we also got null values. So operations, department number 3, does not have anyone assigned to it. Let's look back at the original table. Operation is department number 3. There is no value 3 in this column. So none of these people in the table are assigned to operations. So of course for payroll, there is multiple people assigned to that department. For personnel, and for personnel there is a couple of people. Okay, let's do a right author join. Right author join is where we keep the information from every row from the second table, and for every match we are creating the corresponding we are creating a row with corresponding information from the first row. But if there is no match, we're putting a null. So look through this last name's Watson, department number 6. There is no nothing in the departments table with number 6. We can scroll back and see that our departments go from 1 to 5. And what is this mysterious department number 6? We don't know. However, it's a good way to see what the right join does. And finally, full join is when we keep rows, unmatched rows from each of the tables, departments and employees. And here we say full join. Instead of left and right, we do full. So there were operations, department name, and there were no people assigned to it. That is the second department number column corresponds to employees. There was no employee assigned this department number 3, so that's why there are null values in the full join. And also for last names Watson and Locario, the department number in the employees is 6, but it is not listed in the departments table at all, so it's populated with null values. All right, we can join 3 tables using left author joins, left joins basically. Departments. Here is everything from departments, all the information from departments. Notice that some of them are, or some values are repeated because there are more than one person assigned to payroll and to personnel. That's why they are repeated. So left join, take all the values from the departments table, find all the matches, and for every match create its own row. But also if there was no match, then you will have a column with the department information and nulls for the employees from employees columns. Okay, and also we join on projects. So projects were assigned to people. We are joining by employee ID in both tables, and we get project values. So that is another left join. So everything that was in this table stays, and we are joining the information from projects. So for example, if one person would be assigned 2 different projects at the same time, we would have the same department name, the same last name, and one project, and same information here, another project in the next row. We can join 3 tables using full author joins, and definitely there are differences, so I think even the size of this table is bigger. Since it's full join, we keep, for example, project number 1014 doesn't have anyone assigned to it, but since it's a full join, it gets null values from the corresponding columns. We can combine an outer join and an inner join. This one will be performed first from departments join employees on these keys, and we only keep the department name and last name that have a match in department number in these two columns. And then we do left join, so keeping all the previous results. Left join with employees ID. This is an interim table. Let's think a little bit deeper through it. Interim table after the first join. This is an inner join, so no nulls were created. A last name and employee ID. And when we did another left join, we had apparently a person who was not assigned any project and another person who was also not assigned any project. So when we were doing a left join, for those people, there were no values created. So we keep everything in the left join, we keep everything from the first table. In our case, it is the result of this inner join of departments and employees. All right, cross join. So cross join is not used very often. I only saw it used in a certain data science context when creating a very large tensor. So cross join is a join with no conditions where every row of one table is matched with every row in the other table. So if for example, the size of the first table is 5, the size of the second table is 10, the result will be 5 times 10, 50 rows in the table. So this is explicit syntax. Departments, department number, department name, employee ID, last name. So from departments, cross join employees. Let's go back to departments and employees and count the rows in the original tables. Departments and employees, 5 times 9, 45. We should get 45 a table with 45 rows. This is an explicit syntax. The next page is implicit syntax. You can see that it's basically listing departments and employees with no condition, and that's what cross join is. Create all the pairs, there is no condition. Condition basically would restrict the pairing. And it is indeed 45 rows. So everything from the first table got matched with everything from the second table, one by one. 9 times 5, or rather 5 times 9. So we talked about each of this. I should say that left join, you can only use left joins. You will never need right joins. They are very symmetric. Also, it's a very good idea to pull up something that is available in our week. That is a cheat sheet for various types of joins, SQL joins. This is one of the most important ones, inner join. So think of this each circle as a table, and the intersection is when there is matching keys. And look here, select whatever you need to select, the columns you need to select. From table A, which will alias as A, and inner join table B on A key and B key. So when there are matching keys, we are selecting that, and we are selecting the rows that from each table that we need. This is inner join. Now we have left join. This is just left join. You don't have to say author. So everything from the left first table is included. And if we have matching key with table B, then we include information from the table B. If there is nothing, like over here, there is nothing from table B, matching matching key from table B, then we populate it with nulls. By comparison, left exclusive, take everything from table A that does not have a matching key with table B. So B key is null. That's how you formulate that there is no matching key. So we are excluding all the inner join. That is still taking the list of columns from table B, but populating it with null. As you can guess, it is useful, but not very often. And finally, there is a full author join, and basically it chooses everything from A, everything from B, and if there is no matching in B, there is no matching key from A in B, then we populate the missing values with nulls, and if there is, that is the part that is an inner join. So left inclusive includes inner join, as well as full author inclusive includes inner join. There is a variation full author exclusive, so only choose the ones that don't have a match. And you can read the code, how they filter basically a full author join. They make the full author join first, and then they filter it by the one of the keys should be null. Okay, that is a good cheat sheet to have and to go back to, and you can look at and compare left inclusive with right inclusive and left exclusive with right exclusive, and realize that instead of having right exclusive, you can switch B and A in the code and use left exclusive. So for that reason, you don't need right joins if you can do left joins. These two guys are not symmetric. Full author inclusive and full author exclusive. Feel free to compare the codes here. Okay, let's go back to one more important operation. In some way, it is a very easy one. Syntax for a union operation: basically select statement 1, union statement 2, and so on. So the result set must return the same number of columns. So in each of these select substatements between the unions, between the union keywords, there should be the same number of columns. The corresponding columns have to be compatible data types, and the names are taken from the first select clause from here. Let's look at an example where it's used for a good purpose. So let's just read this statement. Select active as source, invoice number, invoice date, invoice total, active invoices from active invoices where invoice date is after this date. Union, select paid as source, in invoice number, invoice date, invoice total, so the very same columns with the same column names, by the way, and from paid invoices where invoice date is bigger than this. Order by invoice total decreasing. So you wanted to create a new column, source, as you did over here, and you give it value based on whether it is an active invoice or it is a paid invoice. So you are pulling data from two different tables, and you mark which table it comes from by a keyword paid or active. So the structure of each of these select statements is exactly the same, so they have to match, and you put one next to each other, concatenate one with another, and then you can order the result by invoice total decreasing. Union can combine data from the same table, so we are again creating some column source, and we are defining what is active here explicitly, actually, where invoice total minus payment total minus credit total. Remember how it's called, balance due. We had a bunch of examples with it. So we are selecting those rows where balance due is bigger than 0. We are marking them as active in a column source, and separately we are selecting all the columns where, sorry, all the rows where balance due is less or equal to 0, and we are calling it paid and in the source column. And then finally we order it in some way. Okay, so this is a very interesting example, very tricky example, so let us take some time to understand it. So we are creating a value, first of all, where we are taking this from invoices join vendors, and the second one from invoices join vendors. So we are taking columns from inner join of invoices join vendors on the very same key, vendor ID and vendor ID over here, but satisfying different conditions. Where invoice total is bigger than 10,000 in the first place, so all the big totals, and the second one, invoice total between 500 and 10,000. Now let us think about this new string that we are inputting in our table as a payment type. So that is 33% payment. So if the total is large, then somehow we do 33% payment. And if the total is smaller, then we do 50% payment, and we are also adjusting the invoice total as payment. So I guess this is an immediate payment, and the rest of it can be done later. That's the meaning of this. So you are creating in this way. I don't know why they don't give a table, but we can talk through what this means. So we filtered our join invoices, join vendors, where invoices totals were bigger than 10,000. We created a new column for the to mark that as 33% payment, and also we created a new column payment, which is a calculated column calculated in one way. And if the invoice total between 500 and 10,000, then we mark payment type differently with a different value that will appear in the column payment type, and we are calculating payment by a different formula. Okay. Let's see, union that combines. Oh, that's another union continuing from the previous page. This is one SQL statement continued on the next page, and in this case invoice total is less than 500, so we are choosing full amount as payment type in that case when the amount is small, and just as payment we take invoice total. And then finally we order by payment type, vendor name, invoice number. Payment type was 33%, so it's actually, we see a snippet of this table starting from row 6. Payment type was 33% because the total was large. Here payment type begins with 50% because totals were much smaller. And then we are, in this case, calculating 33% payment, and in the other cases 50% payments. So this is the result set. Finally, we need to mention accept and intersect. Instead of union, we can also do accept and intersect. and you can guess what the except means, so select everything from statement 1 except whatever was selected in statement 2. These two select statements should return the same type of columns and the same number of columns for except or intersect to work. Intersect basically takes only the rows that are common between first and second results in corresponding the select statements. Okay, exclude rows from the first query. If they also occur in the second query, that is our except statement. So the result set is the rows that did not occur in this second select statement. And finally, include rows that occur in both statements. Yeah, those are set operations, the same set operations that you may be studying in math. Union is also a set operation. There is no reason to not include it in set operations. So union, except, and intersection are all set operations. And that is it with the lectures, and I will also have an introduction to homework video.